Good afternoon, everyone. This is actually the first time I've been to Singapore. Very excited. I'm very happy to. It happened to be holidays. Very happy to have you. And also special thanks to the AHRFs for the generosity to provide this nice place for this for this meetup. And thanks to Evan for his time to hang out with us. So I'm very happy to share with you something I've been doing in the last 2 years. I hope you, quite a few already know the risk, so I should feel at home. So let's get started. So this is a project I've been working on in the last 2 years. It's MoonBit, which means it has a Chinese name. If you know, it's called Yue Tu. So it's a most people think it's a programming language. Actually, it's way more than that. In my opinion, it's a coding platform. We provide the whole tool chain from the editor, the compiler, the build system, the patch manager, and the coverage, and everything you need for the code development to the development. So it's a platform. And it happens to be in the same time. The team was founded in 2022 October, which was the same time as the ChatGPT announcement. So we found it's a big opportunity to, if we design new language and it's tool train from the ground up, how to make it more friendly for the AI, for the code generation. I think it's a great opportunity for us. So a brief introduction about me. So I've been working in language design actually earlier than 2022. In my bachelor thesis is also about Nippon language called Wukong. It's a small DSL language for animation. So it's my bachelor thesis. Then I went to the UPenn for the PhD, but I didn't finish the PhD, so I have my master thesis, which is a metaphone language. It's called FAN. It can be bootstrapped by itself. And then I'm lucky to be a co-maintainer of the Hongbo in the 2020, I think the 13. Because of that, I was invited to join the Bloomberg based in New York to maintain their own private fork of the Ocaml compiler. And then I was lucky again to have in my hobby time to write a Ocaml to JavaScript compiler, which was called Bacoscript. And my boss is French. You know, the Ocaml was made by French. He's very he liked my work very much. So I'm lucky to work on a open source project for full time, and it happens to be I think it's the most popular open source project in Bloomberg. So I was there working for 3 years on a Bacoscript compiler, and then I was lucky so I decided to move back to my hometown in China. Yes, I'm lucky again. And then the Facebook reached out to me because they already use the Bacoscript compiler in their Facebook chats and I think Facebook Messenger. So the exception, I was allowed to work in my hometown for remotely for 5.5 years until I was also contributing to the Flow, which is Facebook's TypeScript compiler, or Flow.js. Then I dropped out from PhD twice. Once then my PhD advisor he retired from Microsoft. He was very famous. He called Harsham, with I think the EVP of the Microsoft. He went back to the Shenzhen. Then I decided to join him to found a new team, MoonBit. So why I started MoonBit? Because I think risk is really good, and I think, but it doesn't deserve the market share compared to like Dart or TypeScript. There are many reasons for this. I think tech is the only part of the reason. So I believe if I have a full-time team and have a rethink about how the language toolchain should be designed, there's a good opportunity to bring a really mainstream language in my vision. So it's a good opportunity, and I'm glad we actually got quite far in the last 2 years. Yeah, so why MoonBit? As I said, it's just by accident we see actually in my PhD last year, my advisor actually is working on a program synthesis. So the AI code generation is not too strange to me. But before the ChatGPT, most AI code generation, but most prompt synthesis that give you the demo quality is not real for real world. For the first time, we see the AI generated code is really, really good, and we see, oh, it's can we, if it's really big, why? I think it makes sense to have a whole point tool chain from bottom up to design for the large language model instead of like modify the existing tool chain to make them slightly better. And I will show you later. It actually can be do with a really good, much better AI code generation if you rethink from the bottom up way. And the other is the cloud, the WebAssembly. This is because the Watson is all a hot topic, but it doesn't take off. It's still every year. Next year, the major year of the WebAssembly, but it never take off. I think, in my opinion, the major problem with the WebAssembly is they don't have good tone language for people to produce the very high quality of WebAssembly. So the only production language when we study the MoonBit is Rust and C++, and they are not our program language for application developer. They are most for the system programmers. So MoonBit as a new language, if we, in this platform, as a newcomer, if we have like the 10 times better development experience, then we can get our initial users, because it's really hard to sell your new language, I mean buggy and ecosystem incomplete language to a new people, right? You have to deliver, on the website platform, if it's 10 times better than existing alternatives, then you get your first users. Then you start to grow your user base upon that. So this is our strategy to become the number one choice of program language on the website platform. Then we start getting more and more users. This and our scope is way more than that. I will show you. WebAssembly is the entry point to get initial users. So as I said, MoonBit is a platform. It's the whole development tool chain. It has coding, debugging, build, and recovery, testing, deploy, hosting, everything. As of today, I mean, it's not like something we promise in the future. As of today, we already have this kind of stuff, including debugging. I mean, most language doesn't have decent debug. Even for Hongbo today, which has been developed for 30 years, still don't have a very easy to use debugger. But we shipped on the very early for the debugger, and because the MoonBit is, we think that the tool chain is way more important than the language itself. And our key philosophy of the language is the three key words: fast, simple, and scale. The fast means we want the language to compile fast and run fast, not just run fast. And unlike Rust, you actually have very good performance, but it compiles pretty slow. So you want to have both compile fast and run fast. And simple is like you want to keep language simple, like a Go language. I mean, very easy for the newcomer to adopt. So you don't need to spend a lot of time reading the category theory or understanding models. So we want to keep language simple, but we still want to have the reasonable abstraction, like the generics. We don't want to have like take Go for example. They eventually added the generics to the language, but it's almost 10 years later they added generics. So they have some libraries is fragmented. You have to redesign your whole style library because a new feature, generics. So we added the generics and the trace in the very early days. So nothing more, nothing less. The other, the third one is scale. We want to make sure the MoonBit technology is scalable, not a toy technology. This is because part of my experience in Facebook, because the whole in Facebook is a huge amount of repo. So it's unlike the other company which has like maybe millions of lines of code is a large repo, but in Facebook we have like the millions of files. And in millions of files they have given the ID the instant feedback. I mean in less than 100 milliseconds. So we want the MoonBit technology itself scales to the huge amount of repo. So the fast, simple, and scale is our key design principles. And as I said, it's a new language for the very fast static analysis, but also for the code intelligence. So when we call the Challenger IDE, we also call it old style code intelligence, right? So you can combine them together to provide user a very good intelligence experience. And we support multi-paradigm. We support the data-oriented, object-oriented, and imperative. This is quite unlike the reasoning or Hongbo. We believe we still provide the for loop, the continuous break, because I think there's no need to make the new user very hard to adopt. So we still provide the good old style control flow if you like. And we also care about efficiency, as I said. So we also support the efficient functional programming. Yeah, I think in this talk I don't have time to cover this topic, but the MoonBit has a very efficient function style. So you write the code in a very function style, but the general code is like the C style. It's very efficient function style. And we support multi-backend. As I said, Watson is our entry point. It's our entry point to get a new users. But also, I think a few months ago, we provided the JavaScript backend. And we, a few weeks ago, we shipped the native backend. Especially for the native backend, it has very good potential. But we need some time to polish the native backend, give you the bare metal efficiency, if you like. So here's a taste of MoonBit. You can see, as I said, we care about the data-oriented programming. So the JSON is built-in support. You have the JSON data type. I can do the pattern match of data. You can pattern match the JSON directly, and you can write your favorite for loop, and then you can have your favorite pipe to string together. And you can see, and then you have dot means the to-do. It's something I like. So you get the general code. And as I said, MoonBit is very good at tooling. So this actually is not the static HTML. It's the live coding. You can just remove this one, and it will real-time the reflect it. So we have the whole ID in your browser. It's actually, I think, in my opinion, in my impression, is the first actually industrial language which has all your ID, all your compiler running locally in your browser. So actually, you can get for example, you can get instant feedback like this one, give you instant error, and then you can also get the instant completion just in your browser without any container or any. This is why we can deliver this, because I think there are some like Rust, because Rust can be compiled to the WebAssembly. So you can, in theory, you can also put a whole Rust IDE in your browser. But Rust huge, like several megabytes, several hundred megabytes of the IDE downloaded on your client, which is totally unusable. But in MoonBit, we get the IDE feature complete, but in a very lightweight style. So you get all the good stuff. Yeah. This is just the other style. You can have your num, which is very like the Rust, and we see we have like the generics, and you have the derive. So this is something I missed in the risk. You don't have the derive. You have to write a lot of the PBX. We provide this built in for you. So you don't need to write your own deriver. This is another shiny point I want to share with you about MoonBit. So we innovate in the pattern match. So we can also pattern match over the not just list a map. We can pattern match over the array in a very concise style. Here is a function for its palindrome. It's an array view, which is like the Go slice. So you can pattern match the array view. If it's empty slice or it's a singleton element, it returns true. Otherwise, if we test the tail and the body. If it's the same, we continue the rest. Otherwise, return false. So we give you the pattern match of array view. And then more importantly, this is a zero allocation, which means there's no allocation happen in this program. And it's very efficient and very easy to understand. And as I said, it's also a live coding. I can give you just write if I write one, I see false. Everything is works in your browser locally in IDE. Okay, so there are a lot of MoonBit is a full-blown programming language with all the modern features. So I cannot cover in a very short time, but the two slides give you a general idea how it works. So this is our first backend, which is a WebAssembly backend. This is in three key metrics. The first one is the compute time. The MoonBit is slightly slower than Rust, which is reasonable because the Rust is already optimized for many years, but it's way more faster than Go language. And the compute size is even smaller than Rust. Second is smaller than Go, and the compile time is also much faster. I think this is slightly misleading because in real world benchmark the compile time is way faster than Rust because this is only one file, so you cannot get the pain of the built-in Rust. But anyway, this will give you an idea. MoonBit performed really well in 3 key metrics in the MoonBit backend. As I said, which happened to open source the core compiler, and one of the awesome CEO quote the MoonBit is the key distinction. MoonBit is the only language to have the compile to WebAssembly and also supported for the component model. It applies to easily build WebAssembly components. If you're interested in WebAssembly, definitely check out the MoonBit. The other is the backend is as we released the main, it's a JavaScript backend. And you can see the performance actually really good because why? You see the same code style. The left side is the JavaScript code, the right side is the MoonBit style. Very similar, but because we use the whole program optimization, we can fuse all the closures into a single loop. So you can see we are almost 26 times faster than the JavaScript, given that MoonBit still compiles JavaScript. This is of course is a micro benchmark, but in the real world benchmark, we port the JSON 5 parser from the JavaScript to MoonBit, we get like 6 times faster. So if you care about the performance on JavaScript, definitely check out the MoonBit. This one is a hot take. It's the native backend we just released a few weeks ago, and to our surprise, it's still much better than existing technology like Java. So for the numeric computation, MoonBit almost 15 times faster than the OpenJDK and 3 times faster than the commercial compiler, which is provided by the GraalVM, the Java LT compiler. And this is on the numeric computation, so it's maybe a bit biased for numeric computation. For the more general, like the memory management and the performance, like the normal, still outperform like Java or Swift. This is not easy goal, given that Java has been engineered for like 20 or 30 years. So our native backend still needs some polishment, but it's showing some very, very good performance in the future. Because MoonBit can be compiled to the native code, and it can be generate very small output of native code. It can even be used in the MCU, the microcontroller unit. The process, the RISC-V process only have like 100 kilobytes ROM. Can run the MoonBit code and live coding. I can show you that. So we change the code and rebuild, and then you can see instantly the hardware can be reloaded. The whole process is quite smooth. So the native backend opens a new door for the MoonBit applications. So the several key design process principle is the whole language. People will also comment like, oh, MoonBit is something like nothing really major ideas. I think the major idea of MoonBit is we try to get ourselves very constrained. We not try to add every feature to the language. We try to only add some feature which is really necessary to make the language very expressive, but not too bloated like Scala or Rust. I mean, so the key, so then we get all the benefit like fast static analysis and fast IDE service, parallel type checking, and incremental type checking. Also, we have and we care about performance, so we optimize in the whole program optimization. This is also based on my experience in OCaml, which is really not very good at the optimization because the type information is lost in very early days. So give me an example why our JavaScript backend is so fast. It's a char option, optional char. Optional char in most language is boxed, right? It's boxed because you have to do the separate compilation. The optional char for none is okay, but for optional char you have the boxed char. But in MoonBit, because we do the whole programmation, we can optimize the none to a -1 and some char just as char. We have all the type information, and in my opinion, for the good performance, the data memory layout is a key. I mean, if you don't have the good memory model, then all your optimization doesn't really make too much sense. So we care about the performance, and we do the whole program compilation, and we also have very modular compiler architecture. We achieve a lot because we have a very modular compiler architecture. It's very easy for us to add a new backend. I remember it only takes like several weeks for us to add a JavaScript backend. So we have a public. I can just click. Yeah, this is all available, publicly available, the AI Explorer. So you can see we have like multiple backends. You can see all the generic code, and they have a multiple the IR. Yeah, you can, for example, this is for native code, you can generate a machine native assembly code directly, and it's not a static. It's all completely in your browser, so you can type the code, see the generate code on the fly, and you can see inspect all the different IRs. Yeah, like I give you one thing readable is like this one. Yeah, so you can get all the intermediate research, and for the most backend, they share the same IDE service, but the new backend only need to do a few work on top of the existing IR.
So in Go, in target assembly language, you are targeting x86-64.
Oh, it's the Go compile.
ARM 64, for example.
Oh, so the currently we compile to a subset C, and then use the existing system C compiler to compile to native code. So in theory, most platform which support the C program language just works. Does it answer your question? But in the future we have another. In the future, we are also developing our own LLVM backend, and more than that, we also are all working on even more ambitious project next year. We want to rewrite a whole LLVM in MoonBit. It's a very very ambitious project, but we'll see. Yeah. Cool.
So the approach is quite different from Go's approach, where you target assembly language. So in Go, for example, like
Yeah.
cross-compile on my computer, Windows computer, cross-compile to Windows and cross-compile to Mac.
Yeah, it's different.
MoonBit,
It's different country.
can't really do that.
Yeah, but in the midterm, I think in the short term we will ship our LVM backend. But in the long term, we want to rewrite the whole LVM toolchain in MoonBit, because MoonBit actually is a very good language for writing compilers, just like OCaml or any other ML-like language. It's very ideal for writing to the symbolic computation. So it's in our roadmap to write the whole LVM toolchain in MoonBit.
Who is MoonBit targeting?
Excuse me?
Who's your target customer? What kind of developer?
MoonBit, sorry, actually I think I missed one slide. It's a MoonBit user. Yeah, MoonBit is an application developed language. So you like so there are two kinds of programming language. Like one is a C++, Rust, which is a system programming language. MoonBit is application development is targeted to the Java. It's competing with Java, Go, and Kotlin. Cool.
So you target the LLVM?
Yeah, we're working on that. Yeah. So to show you how fast the MoonBit compiles, I give you one example. Is the Mario game, which is written in MoonBit. So it's a live Mario games. You can just play games, and you can see here we do the live coding, then we get the real-time feedback. One single Mario is not fun, so you can change it to 5 Marios, and then I get the 5 Marios. You don't see any comparison happening, because actually there's no caching behind the scene. Just recompile the whole stuff, instantly give you. Then is the IDE, yeah. I see. So this one is also locally on, so you can just go click one and run code. You get the output, and you have all the like the ID service, like the B dot. Anyway, just give you all the instant feedback. There's no container running behind. Fully available on your locally, and AI stuff. I will show you later. Yeah. Cool. These links are publicly available. If you are interested, definitely check it out. So our movie AI. So I think AI coding is something really hot in Silicon Valley, and someone asked, I think the creator of the Copilot asked why there's still no AI programming or computing paradigm happening yet. I think the top reply, actually, I mentioned MoonBit. And yes, that's something we are working on, is to design a new language, the whole toolchain, to make it more AI friendly. I will show you a few work we have been working on. The first one is the constraint decoding. Constraint decoding, what does it mean? So when you LLM, you do a lot of parallel work, but when it does the eventually generate code. When we generate code, the token is generated one by one. So actually it's sequential work. It's not like the parallelized work. So we apply two technologies called resampling, local resampling, and the global resampling. Here we see we have a few tokens like pop. They have a few like 20,000 candidates, X, Y, FN, blah blah blah. So we apply the compiled domain technology. We know the pop X is not a valid MoonBit program, so we can reshuffle the order to make sure the pop FN is actually the generated code. So this will always give you the syntax correct MoonBit code. We call it local resampling because all the domain knowledge is context insensitive. The other technology is global resampling. This is more subtle. Here we have like the partial program. We have some partial program like P and which have type of point. Here we show you definition of the point. But in practice, the point can appear anywhere. It may appear in your dependency, in your transitive dependency. So the large language model doesn't know what point is. So here, and because we have a very, very fast starting analysis, we know the P has a point type. And then we can say, oh, P has only one field called code X. So the first two, then it's not going to give you a type correct result. So you can give you the reshuffle the order to make sure the generated code is more type correct. Actually, this sounds very simple, but it's very hard to achieve. Why? Because the token is generated in a millisecond, in a single digit millisecond. So, and we are given a partial program. We have to do the very fast incremental stack analysis to make sure the generated code to give you feedback in real time, in a single digit millisecond. And then we can modify the generated order to make sure the code is more correct. The other is our concurrent IDE service. So when you write the user copilot, you have a lot of warnings, right? But the copilot can only fix the output one by one because that's how the copilot works. But if we design a new language, we split the program into parallel blocks, and then we can ask in theory we can spawn hundreds, like 100 IDE service, and to concurrently check the generated code. But this is not very efficient. If you design language from the bottom up, you can say we can just give you an API to verify the patch if it's correct in concurrent style. Then you can ask the IDE to verify the generated code, and if they are all verified, then match them together. I can give you a video to show how it works. So here, the first one is we have 4 warnings, right? Copilot only fix you one by one. You can fix them all together in a single click. Fix the warning, fix the whole package. And then we will do the concurrent the agent. And you use the IDE service to concurrently verify the generated code is correct. Then we do the batch processing to make sure the generated code, there's no warnings. Here we also do the concurrent, the document generation, and then verify the generated code, the API actually is correct. Sorry, again? Let me finish. Here the analysis is for the coverage test. Here we spawn almost like the I think the video is not it's not complete. We spawn the agent concurrently like the 68 and generate the code and verify the generated code is correct. And then here is we split we do the IDE validation in const style. Then we can get a coverage increase. Sorry, what's your question?
You say verify means, is it testing?
Oh, so the verify is make sure the generated code actually is type check and pass that, pass the test, etc. Yeah, etc. Yeah. So this is if you don't own the language tool chain, you have to simulate, like you have to make the pseudo workspace and you test each patch, and then you have to launch all the IDE in concurrent style. But we give you just the API, so it's as efficient as you call it, just do a function call. So here's our MoonBit timeline. MoonBit is being made by a very talented program. It's not too many years, like 2 years. We started from 0, and we announced the alpha release 1 year ago. and we open source our standard library and build tool. And just, I think a few days ago, we open source our compiler. And the only major missing block is the async. It's something we have been working on. So I think we are close to give you a preview, and I will leave to my colleague to finish the async story. Thank you.